So what does this mean for us when we're actually working with obtuse angles? Well, for for cos we treat it exactly the same as we did before. So I'm actually going to go back here and just grab grab this so that we have this to look at. So I'll group it so we can shrink it and bring it more if we want. Okay, now we talked about what happens as far as the coordinate system goes. As far as quadrant 1, we know that the x is positive and so is the y. When we look at this quadrant 2, we know that x is negative and the y is still positive. What that means is if I have an angle, which we're going to have, if I have an angle, so if theta, and where'd that go? So if theta, went on the wrong side, equals 135 degrees. So we know that 135 degrees is in the second quadrant. And for some reason, my machine is deciding that it's using too much memory to create the note. So let's keep on going. Then we know that if we take our calculator and we do the cos of 135 degrees, if we pull up our calculator, we end up with negative 0.7071. Okay? And that makes sense because cos is our x value, and so x is negative in the second quadrant. The same thing idea works if I look at the sine of 135 degrees. What I end up here is a positive 0.7071. Okay, now I purposely picked those because those are related to the special angles that we did before. So what happens is no problem when you're asked to find a ratio of an angle. You plug it in, out comes the calculator, gives you the right answer. The problem happens when I go from a ratio back to an angle. Okay, so what happens is when you know the angle, your calculator will always give you the correct ratio. But the converse isn't true. So let's take a look at finding an angle. So you might want to just make a subtitle so that you can go look back at this. So if I look at the sine of 60 degrees, oh, I shouldn't do that, the sine theta of, sorry, I'm just trying to rush, equals 0.8660. Okay, and I need to find what theta is. Well, when I take my calculator, what happens is my calculator will tell me that theta equals, if you take your calculator, it'll tell you that theta equals 60 degrees. And that's true. However, because sine is our y value, it could be 60 degrees, it could be in the first quadrant. However, it also could be in the second quadrant. So because sine is y and y is positive in two different places, it means that theta will have two values. So not just one, it'll have two values. So how do I get that second value? Well, it's related. It's related here because if we're talking about the y, and if I just go across here so you can see, if this is where P is for 60 degrees, it has a value, a y value of decimal 866. So it's got a height of 0.866. But there's also a point over here that has a height of 0.866. So the way we get the second angle is we have a second theta, and I'm going to put a subscript because it's the second angle, and the way we get it is 180 minus the 60 degrees. Okay, and we know that that is 120. Now that's really poor form, people. Two equal signs, never do that. Okay, so what happens is the only time I have to be concerned is when I have sine. So when I have sine, I have to do two calculations. Okay, one that my calculator gives me, and the other one I get by subtracting from 180. Now the same is not true for cos. Cos, there's only one. Okay, so if I have the cos theta, of 0.8660. Again, I'm doing this on purpose because, again, that's going to be a special one. And I calculate with my calculator tells me that that is 30 degrees. Okay, and that makes sense. Okay, now there isn't another one because cos is x. If I want one that's related to this, if I do cos theta of negative 0.8660, what I end up with is my theta. If I take my calculator, it comes up with 120 degrees. Sorry, 150 degrees. Okay, so they're related to each other. However, so when you're going from a ratio and you have sine, your calculator will give you the one in the first quadrant. You have to use your brain to get the second theta by subtracting from 180. What I'm going to do now is I'm going to give you some work to work out from the textbook. Okay, and we'll look at some of this again. Now remember, the problem occurs when you're going from a ratio to an angle, and we're talking about the sine ratio.